Now in true sense, how that multiplication table is constructed, if we have to understand, then we should imagine water molecule properly. And if imagination, consideration changes, then the results will be different. Means sigma xj that I am considering as a molecular plane, and sigma yz a plane perpendicular to the molecule. If somebody says sigma yz is a molecular plane, then results accordingly will change. So what is my convention that I am informing to you? I am assuming water molecule is bent, oxygen is upside and two hydrogens are there down. The z-axis is passing through the oxygen, around which we can perform rotation operation. That's our C2 axis. So 180-degree rotation, hydrogen 1 can come to position of hydrogen 2. Further 180-degree, hydrogen 2 will come to the position of hydrogen 1. I am considering molecular plane as a xz plane. So x-axis to left, right. And yz plane, a plane perpendicular to the molecule. So y-axis towards you and towards me, approaching towards us. Then let us apply one operation, then other operation, then let us ask the question how the result we can obtain from the original, and likewise we can establish the multiplication table. Multiplication table for C2v point group is easy, but for C3v and higher level it will be somewhat tough. But basics should be clear to you, therefore a special video for C2v multiplication table is here. Let us see how is that multiplication table.
In this video, we are going to understand how can we construct multiplication table. First column of the multiplication table, well, that's E, C2, sigma xz, sigma yz. It is just copy and paste of the yellow region column. Similarly, first row of the multiplication table, again E, C2, sigma xz and sigma yz. It is also copy and paste. And diagonal elements identity whichever are there, those also you can easily understand. I mean C2 operation 2 times means identity, and reflection of reflection means identity. So diagonal elements identity, first column, first row, easy to understand. But 6 operations are there. There we need to discuss, and mainly I am going to focus on those 6 operations. For example, C2 into sigma xz, answer is sigma yz, or C2 into sigma yz, answer is sigma xz. How are they coming? Likewise in sigma xz row, you will find 2 operations, sigma xz into C2, which is sigma yz, or sigma xz into sigma yz, that is C2. How are they coming? And last row, sigma yz into C2 is sigma xz, and sigma yz into sigma xz is C2. Logic behind that I told to you. How to remember that we have discussed in the earlier video. But here we are going to derive that. And for derivation, we are considering a water molecule, and water molecule in xz plane. So exactly what it is, how can we do the operation, what will be the result of the operation, how to come to the conclusion of the multiplication, that trick we are going to learn. Now let us see the first result which can be produced by C2 into sigma xz. How does it come sigma yz? That I want to derive. See the derivation method now. It's a water molecule. Let us understand it. Oxygen is there upside and 2 hydrogens are there downside. It's an angular planar water molecule. You will find in the oxygen black dot is there. I want to consider it is a nose of oxygen, or you can say one eye of the oxygen. It means oxygen is paying attention towards us, nose is towards us. So backside portion, nose will not be there, so black dot will not be there. It is enough for us for distinguishing the various results because of symmetry operation. Therefore I am representing oxygen in this funny way. And for hydrogen, simple numbering is enough for us. Left side hydrogen I am considering as first hydrogen, and right side as second hydrogen. Numbering is sufficient, but here I could distinguish by means of color. So number 1 I represented by purple color and number 2 by white color. Molecule is in XZ plane. So how is our x-axis? Left right. How is the z-axis? Up and down. How is the y-axis? Approaching towards us and away from us. So if I perform the C2 operation, then H1 will come to the position of H2 and nose will go away from us. If I perform sigma xz operation, then H1 will remain to at that place and H2 also will remain to the same place, but nose will go away from us. If I perform sigma yz operation, then H1 will come to the position of H2, H2 will come to the position of H1 and nose also will remain towards us. These are the results of the various operation. Let us start to work to find result of C2 into sigma xz. Let me perform the first operation. That's a C2 operation. What do you think? What will happen about the positions of hydrogen? Will they change their position by rotation of 180 degree? Yes, our z-axis is passing through the oxygen and bisecting the angle between the hydrogens. Therefore, certainly after rotation of 180 degree, H1 will come to the position of H2 and H2 will come to the position of H1. Means they will change their position. Okay, it is a one logic. What about the nose? Nose of oxygen will remain towards us or will go away from us? After rotation, it will go away from us. So see now, I represent the resultant structure. Yes, our guess is right. Change in the position of hydrogen and nose went away from us. Now I want to perform next operation. What is the next operation? Sigma xz. And this sigma xz operation I will carry on the second structure, which is a result of C2 operation on original water molecule. Sigma xz is a molecular plane. So if I cut that molecule through the molecular plane and then do perform the reflection, let us talk first about the positions of hydrogen. Will the positions of hydrogen in the second structure change? No. Second hydrogen will remain to left side and first hydrogen will remain to right side. What about the position of nose? Yes, after reflection, nose which was away from us will come towards us. Are you following? See the structure now. Yes, this will be the structure. As I said, hydrogen 2 will remain to its position, hydrogen 1 also will remain to its position, but nose which was away from us will come towards us. This is the result of sigma xz operation on the result of C2. Means, whatever the right side structure you are finding, that is a result of C2 into sigma xz. Now we have to ask question. How can we get that resultant structure from the original structure? See the comparison. In resultant structure, hydrogen 2 is to left side and the nose is towards us only. We are with only four operations: identity, C2, sigma xz and sigma yz. Identity is very simple, there is no change, but here there is a change, so identity option is washed out. It is not possible. Yes, can you guess? How can I get resultant structure from the original structure? Which operation should I perform? Yes, you are right. Sigma yz operation. If I perform, then I will get that resultant structure. Sigma yz means which plane? It is a plane perpendicular to the molecule. Imagine if we hold a plane cutting the oxygen atom and bisecting the angle between two hydrogens. After reflection, hydrogen 1 will come to position of hydrogen 2 and 2 will come to the position of 1 and nose will remain towards our side only. Is the structure which is represented to right side? Yes, therefore I can say the resultant structure of multiplication of C2 and sigma xz can be produced by alone operation, say sigma yz. Therefore, we can say C2 into sigma xz is equal to sigma yz. Likewise, we derive the portion in the multiplication table. We reproduce the result. Let us see what is the multiplication is in multiplication table between C2 and sigma xz. Yes, multiplication is sigma yz. Therefore, we have represented that result C2 into sigma xz is equal to sigma yz. I told you previously only mnemonics point of view. Now we have derived that position, we have derived that result. Similarly, I want to work on a second important result, multiplication between C2 and sigma yz. Let us start. Again, original water molecule, H1 to left side, H2 to right side, oxygen is paying attention towards us, nose is pointing towards us. And I want to perform on this water molecule which operation? C2 operation. How is our C2 axis? Our axis passing through oxygen and bisecting the angle between the hydrogens. If I rotate that water molecule around the C2 axis by 180 degree, what will happen? H1 and H2 will change the position. And what about nose? Nose will go away from us. See the resultant structure after C2 operation. Yes, hydrogens have changed the position and nose went away from us. On this resultant structure, I want to perform next operation. That's which operation? Sigma yz operation. How is our sigma yz? Sigma yz is a perpendicular to the water molecule. After reflection through that plane, what will the result? Second hydrogen, which is to the left side, will go to right side. What will happen for the nose? Nose which is away from us in that second structure, will it come towards us after reflection through sigma yz plane? No. So nose will remain away from us and hydrogen 1 will come to left side. Let us represent the result after sigma yz operation. Yes, hydrogen have changed the position and nose is still away from us. How can we obtain that resultant right side structure from the original structure? See, in original structure, H1 is to left side and resultant structure H1 is to left side. In original structure, nose is towards us and in resultant structure, nose is away from us. What do you think? By which way can we find that? Right. It is possible by reflection through XZ plane. So, what can I say? Resultant structure can be obtained by sigma XZ operation. It's a molecular plane. Because of the reflection through molecular plane, hydrogens in original structure, how are they? They will remain as it is, left side hydrogen, 1. And nose which is towards us will go away from us. So what can we say now? C2 into sigma yz, answer is sigma xz. That's a derivation of the multiplication between C2 and sigma yz. Likewise, each cell in the multiplication table we can construct by this kind of the work. Let us see what is there in multiplication table for C2 into sigma yz. Yes, right. C2 into sigma yz, answer is sigma xz. So we derived now multiplication between C2 and sigma xz and C2 and sigma yz. The other multiplications means important multiplications. Let us discuss them in the next part. Now homework for you. Whatever the procedure we followed to resolve the multiplication, same kind of imagination you have to do for the water molecule and you have to perform C2 operation first. Then what is the result you get after C2 operation? Perform one more C2 operation on the result. You will get final result. How can you get that final result from the original result? That answer you have to find out after the practical work. Write that answer in the comment box. I'm waiting for your answer.